By software.
Speaker on.
Yeah?
On.
Need to
सबसे ना लाइव जा तो रहा है, लाइव जा तो रहा है। उन्होंने ज्वाइन किया क्या? फोन करके पूछिए, उन्होंने ज्वाइन किया लिंक भेजा।
हेलो, ज्वाइन की था, ठीक।
वीडियो आ रहा है उसमें, वीडियो आ रहा है, वीडियो आ रहा है, कुछ लिखा हुआ दिखती है।
पूछता हूँ। हाँ, लिख लिया। हैं? ओके ओके। So, okay students, today we will start the first chapter, that is solutions. Before I start this chapter, I will like to tell you that the chemistry subject is divided into certain divisions. There are 3 divisions in chemistry. If I see the total chemistry for 12th class, there are 3 divisions. One part is physical chemistry. Okay. Now in this physical chemistry, there are 3 chapters. The first chapter is solutions, and the second chapter is electrochemistry, and the third chapter is chemical kinetics. Okay. So these 3 chapters are of physical chemistry, and you know, in this physical chemistry, apart from the subject knowledge, you will be tested for solving the applied problems. That means numericals you will be asked to solve, and they are quite simple. The only thing is you have to practice them very thoroughly. If you do a numerical one time, you may not be thorough. You have to do it twice, thrice after certain intervals of time. And this is quite, you will not forget. Once you read this physical chemistry, you will not forget. And the second portion is inorganic chemistry. In inorganic chemistry, there are 2 chapters. The first chapter is B and F block elements. Students, you have studied periodic table in your 11th class, and you see that there is a block which is present between S block and P block elements. That block is known as D block. This is D block. This is D block. And then there is another block called F block elements. Okay, so there is a chapter where we have to study about D block and F block, right? And the second chapter in inorganic chemistry is coordination compounds. Coordination compounds. So you have to study these 2 chapters in inorganic chemistry. And then there is a third portion, and where we have to study organic chemistry. You know, in organic chemistry there are 4 chapters. The first chapter is haloalkanes and haloarenes, and the second chapter is alcohols, phenols, and ethers. Okay, here you have to study about all the alcohols and phenols and ethers. Then you have to study aldehydes, ketones, and carboxylic acids. And the 4th chapter is on amines. This is also quite important chapter because it's the 4th chapter of organic chemistry, and any examiner, he will try to put some questions from amines. And amines also, surprisingly, it consists of two parts. There is one larger part and there is one smaller part. It is diazomium salts. It's only 1.5 page in NCERT, diazomium salts. It's only 1 or 2 pages, and out of this, definitely you are going to get some questions. There will be some preparations or conversions or other things. And then there is a miscellaneous portion, miscellaneous chapter, and that is biomolecules. So, students who are having PCB, they are studying about biomolecules, but what we will do is, we will be studying from the chemistry point of view. It's also very important and very interesting. Once you do it, you will get maximum marks, right? How many are there? It comes over here. Have number 3. Okay. So these are the chapters which you have to learn in chemistry in 12th class. Look, this portion, it should be studied first of all. Reason, because you learn it in the evening and in the morning it is gone, right? So you have to revise all these chapters at least 10 times, and then you will be confident and you will have an edge over all other students. And this portion, it contains just like physics. These are the physical chapters, and you can learn them very easily. And then you have to, if you have to get excellent marks, you have to master the numericals based on this. And this, for this you have to study only NCERT, and then you can learn and get good marks only if you study NCERT line by line very regularly, and you revise them. Okay. So now I will tell you about the first chapter, that is solutions. Now in this chapter solutions, if you ask me, if I have to set a paper for CBSE, I will set the questions on one topic which is called qualitative properties. This is the most important part, qualitative properties. Okay. Now, what are qualitative properties? What are qualitative properties? Qualitative properties are properties of solutions, and these properties depend upon the number of solute particles. What does it mean? What does it mean? Suppose if I am having a liquid and I am adding some solute particles in this, there will be some qualitative properties which will be observed by us. And if I add more solute into this, then the qualitative property will, the value of qualitative property will become more. That means these qualitative properties, they are dependent on the number of moles of solute, and not on the nature of the solute. Nature के ऊपर they will not depend. So qualitative properties are the properties of solutions which depend upon the number of solute particles but not on their nature, right? So there are 4 qualitative properties which you are going to study. You might have studied all these qualitative properties in your school by now, and I want to briefly revise them. The 4 qualitative properties are RLVP. Sir, what is RLVP? RLVP means relative lowering of vapor pressure. Relative lowering of vapor pressure. Relative lowering of vapor pressure. Right? If somebody asks you mathematically, what is the relative lowering of vapor pressure? Sir, P naught minus Ps by P naught. This is what should be your brief answer. So what is P naught? P naught means the vapor pressure of a pure solvent. The vapor pressure of a pure solvent. And what is Ps? Ps is vapor pressure of solution. You know, the vapor pressure of solution is always less as compared to vapor pressure of the solvent. So why the vapor pressure of solution is low as compared to the vapor pressure of the pure solvent? I tell you. See, I have taken a beaker, two beakers of same size, and in what? In one of the beakers, I have put a solvent, pure solvent. If I see its surface area, it consists of only solvent molecules. This is a pure solvent, and its surface, it will have only pure solvent molecules. And when I put a solution of, say, a sugar solution into this, there will be some pure solvent molecules, there will be some non-volatile solute molecules also. And if I say in other words that the surface area has been reduced. Why it has been reduced? Because some of the surface area has been occupied by the non-volatile sugar particles, right? So the vapor pressure, that is just evaporation. Evaporation is a phenomenon which depends only on the surface. So here vapor pressure will be more, here vapor pressure will be less. Why vapor pressure will be less? Because here the surface area has been reduced. How? Why it has been reduced? Because some sugar molecules, they have taken the place of solvent molecules. Here all of the surface area has been occupied by the solvent molecules. So the vapor pressure of pure solvent P naught is always greater as compared to vapor pressure of its solution, right? So if I ask you how much lowering of vapor pressure has occurred, sir, P naught minus Ps. P naught was the vapor pressure of pure solvent, and Ps is the vapor pressure of solution. So P naught minus Ps is lowering of vapor pressure. And if I ask you what is the relative lowering of vapor pressure, what does it mean? Sir, the total vapor pressure of pure solvent pressure, it's a qualitative property. Now there is one more question which is usually asked to pressure. It's a qualitative property. Now there is one more question which is usually asked to confuse the students. Is lowering of vapor pressure a qualitative property? No sir, it is not a qualitative property. Is relative lowering of vapor pressure is a qualitative property? Yes, it is a qualitative property. That you will know when I tell you that this relative lowering of vapor pressure is equal to chi V. Sir, what is this chi V? Chi V is the mole fraction of the solute. Okay, this is the first qualitative property which you are going to study. And the second qualitative property which you have to study is delta TV. Delta TV. Sir, what is this delta TV? This delta TV is known as elevation in boiling point. It is known as elevation in boiling point. So you will like me to explain you what is elevation in boiling point. Look. Yes. Stop. Okay. Delta TV, boiling temperature, this represents the change. Suppose a liquid boils, let's think of water, it boils at 100 degrees centigrade. Another important question which is set is, when does a liquid boil? A liquid boils when the vapor pressure of that liquid on raising temperature becomes exactly equal to the pressure above it. Okay, if I boil water at sea level, where the vapor pressure of the water will be 760 millimeter mercury, and also the atmospheric pressure is also 760 millimeter of mercury. So it is at 100 degrees centigrade when the water has a vapor pressure of 760 mm of mercury. So water boils at 100 degrees centigrade, right? Now, if it is a solution, which is containing some non-volatile solute, then the vapor pressure of the solution will be much lesser than the vapor pressure of the pure solvent. So at 100 degrees centigrade, this vapor pressure will not be equal to the 760 millimeter vapor pressure of the atmosphere. So it will not boil at 100. Then what we have to do? We have to raise the temperature further. Suppose if we raise the temperature 102 degree, then it will start boiling, right? So I will say that there has been an elevation of boiling temperature. How much? 102 minus 100. So this is delta Tb, elevation in boiling point. That means 2 degree boiling point has been elevated just when we have added some non-volatile solute to the pure solvent. So what is delta Tv? Delta Tv is the difference in the boiling point of the solution and boiling point of the pure solvent. Boiling point of the solution and boiling point of the pure solvent. Right? This we have to study. This is also a colligative property. And the third colligative property which we have to study is delta TF. Sir, what is this delta TF? Delta TF means freezing temperature, change in freezing temperature. You know, the freezing temperature of water is 0 degrees Celsius or 273, if I want to be exact, 273 Kelvin. Okay, and if I add salt to this water, it will not freeze at 273. The freezing temperature will go down. That means it will freeze at a temperature lower than 273. Suppose this is the freezing temperature of the solution and this is the freezing temperature of pure water, then this is lower as compared to TF naught. So delta TF, it is the difference between TF naught and TF. So how we will define delta TF? Depression in freezing point is the difference in the freezing point of pure water and freezing point of the solution. So this also is a colligative property, because once we discuss in detail, you will find that it depends directly on the weight of the solute particles. So it's a colligative property. The fourth colligative property which you have to study, that is the osmotic pressure. Okay, osmotic pressure. Sir, what is osmotic pressure? Before I explain you the osmotic pressure, I need to tell you what is osmosis. Children, you have been doing some experiments in your rural classes. You take a potato, peeled potato, then you make a groove into this, and suppose if I put sugar solution, say 40% sugar solution in this, 40% sugar solution, that means it will contain 40% sugar and 40% water, 60% water. Okay, and if I put this potato in a bucket full of water, now outside the potato, the percentage of this water is 100%. Right? All these cells of potato, they act as a semi-permeable membrane. Sir, what is a semi-permeable membrane? Semi-permeable membrane is a membrane which allows only solvent molecules to pass through it and not the solute molecules. Why? See, this is semi-permeable membrane. It has got certain pores in this, but the solute particles, they are larger. Solvent molecules, they are smaller. They can pass through these pores and solute molecules cannot pass. That is why we call such a membrane which allows only the solute molecules, they don't allow solute molecules to pass through, they allow only solvent molecules to pass through these pores. Okay, now these are all semi-permeable membrane. So what will happen if you put a pin over here to know the level of the sugar solution which we have put? After some time, what will happen? Water will start moving into this and the level will start rising. Okay, so you will find that the level of the sugar solution will go up. This process in which solvent molecules from the region of their higher concentration, they have moved to the region of their lower concentration through semi-permeable membrane is known as osmosis. So this is osmosis. If you have to define osmosis, it's a process. So what happens in this process? There occurs a movement of solvent molecules. From where? From region of their higher concentration to a region of their lower concentration. So this is known as osmosis. And one more thing I want to tell you, osmosis is different from diffusion. See, if I take water in a beaker and if I put a ink drop into this will also spread. Ink will also move from the region of its higher concentration to the region of its lower concentration, but it's not through any semi-permeable membrane. So such a process which does not require any efforts, this is known as diffusion. So diffusion is different. The main difference is the presence of semi-permeable membrane. It is present in osmosis and there is no semi-permeable membrane. Now, you have to understand what is osmotic pressure. Again, I am taking a U tube made out of glass, and here there is a semi-permeable membrane. On one side, I put a thick solution, say 40% solution, 40% sugar solution, which contains 60% water, and on this side of the semi-permeable membrane there is a 60% water. It has got 100% water, and here the water percentage is 60%. So after some time, this solution, the solvent, will tend to move from the region of its higher concentration to the region of its lower concentration, and the level of this solution will tend to rise. Suppose if I ask you, let us stop this, let's not allow this solution to go up, and we apply some pressure on this just to stop the process of osmosis so that the level does not rise up. That minimum pressure which we need to apply just to stop the process of osmosis, it is known as osmotic pressure, and the symbol is pi. So pi is osmotic pressure. How we will define osmotic pressure? So it's just the pressure which need to be applied on the solution side to stop the process of osmosis. Okay. Now if we apply a pressure greater than this, greater than osmotic pressure, you know what will happen? This, from this side, that means from the concentrated solution, the solvent molecule will start moving in the opposite direction. That means the process of osmosis will get reversed. This is known as reverse osmosis. This is known as reverse osmosis. And you know this reverse osmosis process has got its own importance. In all your kitchens you are having a RO plant, okay, that is reverse osmosis. And you know all these Arab countries, they don't have water in the ground. They take their water. How do they use? From where they get their water? They have a they get this saline water. They get water from sea. They put this saline water into this side with the inlet, and there is a semi-permeable membrane, and the system is airtight, and here it is saline water, the water from sea, and then they apply a pressure greater than the osmotic pressure. They apply pressure greater than osmotic pressure on the solution side. As a result, what happens? The water molecules, they start moving from sea water towards the other side, and we get pure drinking water. We get pure drinking water here. This process, in which we remove the salts present in the sea water by the process of this reverse osmosis, is known as desalination. So desalination is a very, very important process which we use in getting pure water, drinking water from sea water. So these were the 4 qualitative properties, and if somebody asks you, why do we study these qualitative properties at all? Sir, we study all these qualitative properties just to find out the molecular masses of unknown substances, to find out the molecular masses of unknown materials. We can use all these 4 properties to find out the molecular masses, right? But which one is best is the most important question which is repeated. Sir, it is osmotic pressure which is the best qualitative property to find out the molecule, to determine the molecular mass of an unknown substance. Reasons. The first reason is this osmotic pressure, it is done at room temperature. right? There is no need to increase or decrease the temperature, because there are certain chemicals, if we heat them, say if I want to find out the molecular mass by delta TB, elevation boiling point, what will happen? What will happen if I want to find out the molecular mass by delta TB method, elevation boiling point? The nature of the material will get destroyed. There may be denaturation, there may be polymerization. So, as compared to this delta TB, this osmotic pressure is a better process. And there are certain things which cannot withstand cold temperature. Okay, their nature gets changed. Okay, alright. Then this delta TF is also comparatively not as good colligative property for determination of this molecular mass. And another important thing is this: when we determine the molecular mass by osmotic pressure, this method is very precise. For a little change in concentration, even if there is a little change in the concentration, the colligative properties changes to a very great extent. So such methods where a small change in the colligative, small change in the concentration brings about a bigger change, larger change in the value of colligative property, is definitely going to be more precise. So if I have to explain that this process is carried out, osmotic pressure is measured at room temperature, there is no need for raising or cooling down the temperature of the solution, and the material will not be affected, its nature will not be changed, and also this method, osmotic pressure being precise, is definitely preferred for determination of colligative properties and molecular mass. And important thing which I want to tell you, that the colligative properties and molecular mass, they are inversely proportional to each other. Okay, that is all which I wanted to tell you about the colligative properties. The rest we will do in the next class. Okay, thank you very much.
Thank you sir.
कितने बच्चे हैं इसमें? 2-3?
दो थे लास्ट